Yo, what's going on guys, Tanmay here for Simple Snippets and welcome back to another video tutorial on data structures and algorithms. So in this video tutorial, we are going to be taking a detailed look at the singly linked list. Now if you've been watching this entire data structures and algorithms playlist, in the previous video tutorial we discussed in detail what exactly is a linked list data structure. We also took a comparison between linked list and array, and we saw behind the scenes what happens in memory when you create a linked list. We also saw the different types, the operations and its applications. So it was a very detailed video, and if you're a beginner, if you don't know what linked list is, I would recommend that you watch that video first and then you come on this type of linked list, which is singly linked list. Now starting off with today's topic, which is singly linked list, which is a type of linked list, we're going to be dividing this topic into two parts again. So this would be part 1 of singly linked list, and in part 2 we will actually write the code in C++ program to implement the singly linked list. But it is very important that you actually understand what exactly is singly linked list and what happens behind the scenes when you create a singly linked list and the approach that we are going to be applying. So when it comes to linked list data structure, if you Google out the different implementations, there are many different codes which basically perform the same operations in different ways. So that's why it is really important that you understand what happens behind the scenes and understand how our approach is going to be. So in this video, we are going to be covering exactly that, and we'll see all the operations and how we are going to be performing. We'll also see a little bit of algorithm and pseudocode which we will implement in the next video. So I would request you guys to watch this video till the end. It is really important, and I have got this general feedback from beginners and IT students that linked list topic is kind of difficult compared to the stack and queue data structure. I would say that it's not really difficult, it is a little tricky, because then it involves the concept of pointers and it also involves object-oriented programming concepts. But I will try to make this video as easy as possible, and I have written the code myself, so this would be my own implementation. So that's why it is really important that I explain it to you, so that in the next video when you actually type in the code, everything would be clear. Okay, so enough of the intro, let's dive into the topic. Let's start off. So quick recap, these were the three different generic types of linked list. We had singly linked list, doubly linked list and circular linked list. We are going to be talking about this one. Now in this linked list, we only have one pointer, which is next pointer, inside a node. So this is a node and the next pointer points to the next node. Okay, so if this is n1, this is n2, this is n3, right? So in doubly linked list we have a previous pointer also, so we can come back also. In singly linked list we can only go ahead, that is we can only traverse from n1 to n2 to n3, but we cannot come back. In circular we can go in one direction and come back, but we have to navigate throughout the linked list. Okay, so this was covered in the previous video. Now let's actually dive into singly linked list topic. Now we have 6 generic linked list operations. There can be many more, but these are the standard ones that we are going to be trying to implement. So the number one is traversing a linked list. Now mind you, this is a singly linked list. So in traversing, what we are doing is we are going from n1 to n2 to n3, and this is the function that you have to implement. This one is going to be the head node. Okay, so this was traversing. Second one is appending a new node. In appending, we are going to add a node at the end, connect it, and that would increase the length of the linked list by 1. Okay, so this would be d and n. In prepending, what we do is we add a node but at the beginning of the linked list. We make the connection d n, and one small change that the new head is going to be this one. Okay, fourth is inserting a node at a specific position, so that would be the insert node function. So let's say you want to insert a node over here. So what you have to do is you have to make this connection over here and this connection over here and remove this connection. So now it would be 1, 2 and 3. Similarly, if you want to delete a node, if you want to delete the last node, you simply have to erase this link and then only 1 and 2 will be remaining. But if you want to actually delete the center node, what you have to do is you have to connect this one to the third one and then erase these two links, right? So that becomes a little tricky. The sixth one is updating a node. So when you talk about updating, we are updating the data. So D stands for data and N stands for the pointer which points to the next node. So let's say you want to update this third node. So we have 1, 2 and 3. This is the head. So we have to traverse from 1 to 2. We have to check what data is in it and we have to change it. Now remember, when you want to update a node, we have to identify the node by some unique identifier, right? So in that case, what we will be doing is, in the actual implementation, we will add one more data in this node, that would be the key. Okay, so there would be a third value attached to the node which would be key. Now this key value would be unique identifier to that node, which means that one node can have only that particular key. So let's say if this key value is 20, no other node in this linked list can have 20. Okay, so that's our implementation that we will do in the code. Now the reason to do that is when you are updating a node, we need to know exactly which node to update, right? And the way we find that exact node, unique node, is by using this key value. So we will traverse to node 1, we will check the key if it is 20. If not, then we will move forward. We will check the node number 2, we will check if key equal to 20. If not, then we will again move forward, and so on and so forth till we actually find a node which has this key. And once we find that key, we will update the D value, that is the data value, change it to D2 or D3 or whatever value you want to insert. And that's how you use the updating functionality. So I hope these 6 standard functions are clear. This was also discussed in the previous video, but then I recapped it for singly linked list because these are the same operations that we're going to be implementing. Okay, so now let's see a little bit of algorithm and a little bit of code when it comes to creating these individual nodes and the singly linked list. Okay, so when it comes to the implementation part, obviously we are going to be writing some code, and in our case we are going to be writing C++ code, right? So as you can see on the left hand side, what I have is I have created a class node. Now when it comes to programming or implementing this singly linked list, what we are going to do is we are going to be using the concept of objects and classes, and we are going to write a separate class which is going to be node class. Because you can see that in our node object, we want 3 data members. So the first one is K, key, D is the data part, and next is a pointer which points to the next node. Now obviously in C++ we do not have an inbuilt data type which has these 3 data members, right? So that's why we need a user defined data type, and we are going to be doing it using classes. Now you can also use structures. If you're using C programming, you can use structures. We are going to go with classes. It's going to be pretty much the same. Inside our class, as you can see, we have these 3 data members, int key, int data, and we have one pointer next whose data type is also node, which is actually the same as our class. Now this is because we know that our pointer is going to point to an object which is also of the same data type, right? So that's why it should have the same data type. Now I am assuming that you guys know the concept of pointers, know the concept of classes and objects, but if you don't, I will drop a link of the entire C++ tutorials playlist for beginners that I have created. You can go through that. In that, just check out the classes and objects, just check out the pointers concept. I've pretty much tried to explain it in very simple way, and I'm pretty sure you'll understand it, and then you can come back to this video. But it is really important that you know those concepts, because anyways in the next video we are going to be implementing this entire code. So this is our class. We have 3 data members, and then we have the constructor. We have parameterized constructor inside which we are passing the key and data. We are not passing any pointer because we are saying or setting the value of null when you actually create the node for the first time, okay, using the constructor. So this is a node. Now this is not exactly a list, okay? So this is our class, and over here you can see this is our main function, okay? Now inside this, as you can see, what I'm doing is I'm creating an object of this node class n1, and I'm passing key as 1. So you can see it is taking int k and int d. K is the key, we are assigning k to key, and we are assigning d to the data, right? So the first value is key value, the second value is the data value. So I'm saying node n1 equals to 1, 10. Now what is happening in the computer memory in the program when it is running? Behind the scenes, a memory is allocated to this object n1. Inside that object we have an integer variable key, which is this is key k, this is the data d, right? And this is for the next pointer which is actually currently holding null because we are calling the parameterized constructor, okay, right? And of course this object location in the memory will have some address. Let's consider it as hash 10, okay? This is the address. Now I create one more object of the same class n2 2,20. Let's say it is created at a memory location hash 70. It has the key as 2 and data as 20. And again, when you create for the first time, the pointer is gonna be null, okay? So that's why there is nothing over here. But now you can see that this is just creating objects of class node. This is not really the singly linked list, right? We have not yet created the linked list. So what exactly would be the linked list is when this n1 will point to n2, right? So let me use another marker. So when the next pointer, that is next pointer inside n1 will point to the node n2 or vice versa, the way in which we want, only then we can call this as a linked list, right? So n1 should be having the value of hash 70, which is the address of n2 object, right? Now obviously we know that in linked list the nodes are not at contiguous memory locations, so they are not right besides each other like arrays, so they are anywhere in the memory, so that linking has to happen, right? Right now when we create n1 and n2, what we've done is we've just created two separate objects which are there in the memory, but there is no linking. So that's where we have to create one more class named singly linked list, and in that class we will perform this linking. Okay, so let's see how that happens. Okay, so right now what we've created is n1, n2 and n3. We'll actually comment this out. Let's assume that right now we are not creating these three, or we are not executing these 4 lines. Just assume that these are comments. Okay, so right now we only have n1 and n2. And now on the left hand side, what I'm doing is I'm creating one more class named singly linked list. Okay, inside that class in the public section, I have only one data member. By the way, when you are creating classes and objects, when you're using the concept of classes, the data members usually are kept in the private section and the methods are in the public section. Right now, to simplify, I'm just including everything in public section so that we can directly access it. In the code also, I'm going to do everything in the public section. But if you happen to keep the data members in the private section, we have to use the concept of getter and setter method, so that would just increase our code. Okay, coming back to the topic, in our class singly linked list, so this is another class along with the node class. We saw the code for the node class, right? So this is another class which is named as singly linked list. Inside this, I have only one pointer whose name is head, and the data type of that pointer is node. So this head pointer will only point to objects which are of class node. Okay, and all the 6 different standard functions that we are going to be implementing. So now coming to our code, let's assume that we have created n1 and n2, n3 is still commented, and now we create an object of singly linked list s. So this is that object s, and we are passing an address of n1. n1 is this node. We are passing the address. Okay, now we also have the concept of pass by address, pass by value, pass by reference. If you still are confused with this concept, I have a very clear video explaining the difference between the three. I will link that also in the video description. It's there in that C++ programming playlist. So we pass n1 by address, and when we first create this singly linked list object s using the parameterized constructor, what we do is inside this object, inside the s object, we will say head equals to n1. Okay, so basically now our head pointer is going to be n1. So in the memory, the head pointer is now n1. Okay, so somewhere in the memory, we are creating the object s, which is of singly linked list type. Inside that we have head pointer, and that head pointer is now pointing to this n1 object. Okay, so I hope things are clear now. Okay, now let's uncomment this statement. That is, let's see the append node function or append node operation. So I'm saying s.append node because this append node is inside this singly linked list class, right? So object of singly linked list only can directly use or access this method by using the dot operator. So I'm saying s.append node, and now I'm passing second node n2 as address. So in the append node, what we have to do is we have to make this connection of n1 and n2. Now at this first line, we have already said that n1 is our head node, right? So at this second line, what we'll do is we'll access this head node using this head pointer, and we will say head.next, that is the next pointer inside this n1 to point to the address of n2 that we pass over here. So now this linking will happen and the value stored would be hash 70. So this is what I mean by append node. Appending always happens at the end of the list. So right now, initially we only had n1 and it was basically the end of the list, right? So when we do append node, we have appended n2 and now the end of the list is n2. Okay. So I hope you are understanding what we did over here. And to actually visualize this as an object of singly linked list, this is basically what is happening. We have just made the connection of n1 to n2. So the address hash 70, which is the address over here, is now stored in the next pointer of n1. Okay, so now n1 points to n2. So this connection is made. So now you can see that the singly linked list is created. Let's see at this line, that is s.prepend node. So this is another operation, right? So prepend always happens at the start of the node. We just saw that in the operations, right? So basically now what is happening is, we know over here this is the head. Now I'm saying prepend node n3. So we've created n3. So let's create that. Let's say we create n3 over here. in the memory, and we are saying key is 3, right? Key value is 3, the data value is 30, and when you first time created, the next pointer is going to be null, right? Now we are saying prepend node. So in prepend node, what is happening is right now in our S object, the head is pointing to N1. So what we have to do is we have to make this head point to this newly created object N3, so that N3 becomes the start of the node. And visually, this is how it would look like. We will create one node over here, N3, who's having 3 as the key, value as 30, and this is N3, right? This is N1 and N2. So right now the head is pointing to N1. So we have to erase this out and we have to make head pointer. Now this head pointer is inside the S object of singly linked list. We have to make it point to N3. So in the memory, this we have to erase and the head pointer will now point N3. Okay, so this is what we will do in the program. And we have to make N3 point to N1, right? We also have to make this linking, right? Otherwise the chain will be broken. Now we know N1 is stored at an address of #10. So #10 should come over here. Okay, and #10 should come over here. So when we actually implement this programmatically, first we have to make this linking and then we have to change the head linking to N3, and it has to be in that order only. Okay, so just to reiterate everything, when N3 is created and when we say prepend node, first we have to link this N3 to N1. So first this linking has to be made, that is N3 to N1. So N1's address is going to be stored in N3 and only then the head pointer has to be changed to N3. That is, this pointer has to be pointing to N3. And if you do not do in this order, the link can be broken. Okay, and you'll understand that in the program. I'll try to again explain it over there also. Essentially, if you don't do it in that order, that is, if you don't first link N3 to N1 and directly point head to N3, what will happen is, in fact, let me just actually show it to you. So let's say you create N3. Okay, in the memory N3 is created. Right now it does not have anything in the next pointer. So what you do is, instead of pointing N3 first to N1, what you do is you change the head which was pointing to N1. So you change this and you make head to point N3. Okay, so let's say head is over here and this is a pointer, right? So you make head pointer to point N3. So let's say this N3 is at an address of #90. Okay, so the head pointer will have now #90. But now if you see, you cannot make this N3 point to N1 because in the program we don't know where N1 is residing. We know that N1 is at #10, but in the program the only value that was storing this address was this head, right? Initially head was pointing to this value, which means head had the address of #10. But if we actually first change it to 90, that is, if we change it to N3, now we don't know where N1 is. So this link can never be made. Okay, I hope you are understanding this, because in the code what will happen is we will not be able to link N3 to N1 if we point head first to N3 and then try to link N3 to N1. What we have to do is we have to first make N3 to point N1 using the head initially, because initially head would be having the value of #10, right? So we can say N1.next points to the head, and then we can change the head and we can make it point to N3. Okay, so this was the prepend node concept. Now moving on to insert node, delete node and update node. So we've already seen prepend and append. Now let's see insert node. So when it comes to insert node, we will be inserting the node at a particular location wherever we want. And the way we can decide where we want to insert that node is using this key. So that is the reason why we require this key value in the node. So when I say insert node at particular location, let's say I pass the key as 2, what I will do is I will traverse the entire linked list starting from the head, obviously. So I'll see if N3 has the key of 2. Now we know N3 has the key of 3. So then we will move ahead. Now I'm gonna say, does N1 dot key equal to 2? We know that N1 has the key of 1. So again I'll move ahead. When I move to N2, I'll find the key 2 equal to 2. So I know that I have to insert node after this N2. So I'll create a new node N4. Let's say key is 4, value 40. So in the memory, a new value will be created. Okay, so let's say this is that node N4. Okay, this is N4. with the value of 40 and key as 4. So key is 4, value is 40. And when I'm saying insert node after N2, we found N2 key is 2. So that is what I have passed. So I'll attach N2, which is this node, to N4, right? So in the address or in the next pointer of N2, I have to store the address of N4. So let's say N4 was at address hash 50. So this hash 50 will be stored over here. And this is how the linking is gonna happen, right? The next pointer inside N4 is gonna be null only, because we are basically creating a node over here with key as 4, value as 40, and we are linking N2 to this new node. So you can see our singly linked list can be dynamically increasing in size, and it can also decrease in size depending upon if you want to delete the node. Okay. So right now the head node is N3, then we have N1, N2, and we have newly added N4 over here. So this is insert node at a particular key. Now this was for inserting a node at the end, right? So we inserted a node N4 which was inserted at the end, which basically was like an append node. What if the key was 1? Okay. So let's see what happens over there. So now let's say our key is 1. Okay. So in that case, again we will start traversing from the head node, which is N3. In N3 we know that key value is 3. So 3 not equal to 1. So we will move from N3 to N1. Now here we know that the value inside the key of node 1 is 1. So 1 equal to 1. That is what we passed, right? So we know that we want to attach a node after N1 but before N2. Okay. So this is what our insert node function can be. Now it can also attach that node before N1. But in our code, what we are going to do is we are going to append or add the node after N1. That is, wherever the key value matches the node, we will add the node after that particular node. Okay. You can also add that node previous to that matching node. But in our code, what we are going to do is we are going to attach it somewhere over here. Okay. So let me create that node just for representation. So that node will be over here. The node value N4 would be 4. Data would be 40. Key is 4. And now what we have to do is, now you can see it is somewhere in between N1 and N2, right? Which means that there are two linkings that have to happen. The first one has to happen from this node N4 to N2. Okay. Which means the address of N2. Now the address of N2 is 70. That has to be stored over here, hash 70. The next linking has to happen from N1 to N4. So instead of 70, the new address of N4 we know is, let's say, hash 55. Okay, let's assume it's hash 55. So instead of hash 70, the address now stored inside the pointer of N1 has to be hash 55, because this is the address hash 55. So now this would be linked over here, and obviously then this link will be broken, right? So this is how inserting a node in between two nodes will happen. First, that node will be obviously created. Then that node will be attached to the next node by storing that address of the next node into the next of that previous node, that newly created node. And then the linking will happen from the previous node to the newly created node. Okay. So this is that insert node at a specific location. So now in the memory, this is how it would look like. N1 will now point to N4. So you can see N1 was pointing to N2, right? So this would be erased, and N1 will now point to N4. So it would store hash 55. N4 will point to N2, right? This is N4. This is N4. N4 is going to point to N2. So it will store hash 70. So now the linked list will start from N3. This is N3, which is head. It will move to N1. From N1, it will not go to N2, it will go to N4. And then it will go to N2. So I hope you're understanding this concept. I know I have drawn a lot of things over here and it might get a little confusing. But visually, I think it is more clear rather than just explaining the text or rather than just explaining the code. Now the next one would be delete node. Just like insert node, we have to pass the key. Whatever key value we pass, we have to delete that particular node. So if I pass 1, I have to delete node whoever has the key of 1. So when I pass 1, I want to delete node N1, right? So when I delete node N1, what I'm actually going to do is I'm going to make or erase this connection which is happening from N3 to N1. And instead of that, so basically what I'm doing is I'm just erasing this connection, and I'm gonna make N3 point to N4 directly. And then I'm also gonna erase this connection and this connection. So if I just erase the connection, I don't even have to delete that object. I have to just change the address of N3 and make it point to N4 directly instead of N1. Okay. So now whenever I traverse the entire linked list, I will go from N3 to N4 and N4 to N2. So in the memory also I have to make those appropriate changes. Right now I'm not doing it because it's become a lot of mess over here actually. So but you get the point, right? When you want to delete the node, we just have to pass the key. We have to find that key in the entire node, starting from traversing from the head node till the end, till we find the key. If we do not find the key, obviously we can show a message that no node exists with that particular key, and we can show error also. And lastly, we have to just use the update node. Now in update node, what we will do, again we will pass the key. Let's say if I pass key value as 2, I will check for the node whichever value or whichever key is 2. So you can see that N2 is having the key of 2. So in that case, I'm also going to pass the value or the new value. Okay. So over here, the function would be actually, there would be a comma over here. We will also pass value that we want to change, right? So there will be two parameters that we will pass in the update node, the key and the new value. So if I pass the key as 2 and the new value as 55, so I will check all the nodes wherever the key is 2. We will find this N2, and inside N2 we know the value currently is 20. We have to change it to 55. Okay. So that's the update node. Okay. So these were all the different operations, and this is how visually everything would look like. And now once seeing it visually, I hope you have a good understanding of how the code is also going to be looking like. We will be creating all these different methods in the class singly linked list. We will create a separate class of node which will have these 3 data members, and then we will make the linking using these methods of append node, insert node, prepend node, and so on from the singly linked list class. Okay, so that's it for this video, guys. I just wanted to show you visually how everything is going to be looking like, so that you understand the algorithm that we're going to be using, the approach that we're going to be using. In the next video, we will actually start typing all these codes for all these operations, and we will create the class node, we will create class singly linked list, we'll create the objects in the main to main, and so on and so forth. So that's it for this video, guys. If you like this video, if you understood the concept of singly linked list, how it looks like behind the scenes in memory, please give this video a like, do share it with your friends. Let me know in the comments how this video was, and I'll see you guys in the next one. Peace.